right, so for your final exam here for Unit 3, I know we're going out of order a little bit, but this is the shortest unit, so it's the one I'm doing on the short day. Okay. The important stuff from circular motion and gravitation. You definitely need to know the principles, okay, of circular motion. This was actually something that didn't go well on our unit exam. There were a couple of multiple choice questions about this on the unit exam, and there will be on the final, okay, on how circular motion works or the nature of circular motion. If something is going to move in a circle, what is required? A centripetal force. Okay, so we have to have a centripetal force, and that centripetal force is causing the object to do what? Don't say move in a circle, because I already said that.
Move towards the center.
Not move towards the center, but something towards the center. Okay, something towards the center. Something towards the center. Accelerate towards the center. Okay, there is a centripetal acceleration. Now, here's the question that went poorly on the unit exam. Uniform circular motion is an example of which of the following? A, an object moving at a constant velocity. An object moving at a constant speed. An object undergoing non-uniform acceleration. Okay, and I can't remember what the fourth option was. Okay, a lot of people picked constant velocity. Is the object traveling at a constant velocity?
No, because the direction is changing.
The direction is changing. Is it traveling at a constant speed? Yes. Okay, but people didn't like that answer for whatever reason. Okay, remember, the speed is constant, right? I mean, all of our formulas involve that speed, not the final, not the initial, that constant speed, right? This is v squared over r, okay? V equals 2 pi r over t, okay? We're not calculating a velocity in any of those situations. It's the speed of the object, and it is constant for uniform circular motion. Is it constant in vertical circular motion? No, right? But where does it go fastest in vertical circular motion? At the bottom, right? So not only is the velocity changing in vertical circular motion, so is the speed, okay? That's because vertical circular motion is not uniform circular motion. Okay, so make sure you review that stuff in your notes, okay? Because that'll be important. There will definitely be some multiple choice questions about the nature of circular motion, uniform circular motion. Okay, the types of problems that we solved were things like banked curves, unbanked curves, okay? So the two types of curves, right? I would say you need to understand how they work, not as much solve problems related to them. Okay, obviously on a final exam, I can't test everything, right? At least in terms of written response, it would take too long. So some of the stuff that was in the written is going to be multiple choice, and it's going to be less about calculating and more about understanding how it works. What keeps you in an unbanked corner? Friction. Okay, what keeps you in a banked corner? The normal force, or at least the horizontal component of it that's pointed back towards the middle. That's why we bank the corner. Okay, so that the normal force pushes perpendicular to the surface and has, okay, so if this is my banked curve, and like this, we bank it so that the normal force will push out and we'll have a horizontal component that is acting towards the center of the circle. Okay? And then we'll also have a vertical component that will offset gravity and keep us from falling in. Okay, so definitely understand how the curves work. We also talked about artificial gravity. Okay, again, probably not something I'm going to have problem solving on, but something you might want to understand for a multiple choice question. Okay, we produce artificial gravity by putting somebody on the inside of a spinning drum. Okay, and we use their inertia to push against the drum, so the drum pushes back towards the middle, makes them feel like they have weight, and pins them to that wall, or floor, we'll say. Okay, and then, we went on to vertical circular motion. I would say you probably would have a vertical circular motion problem. Okay, that would be a written response item, but there could also be some multiple choice about vertical circular motion, just the principles of it. Okay, like what we talked about, you're fastest at the bottom, okay, slowest at the top. Are there any spots where you could possibly feel weightless?
Yeah.
Okay, are you actually weightless?
No.
You are apparently weightless. Apparent weight, another term, okay, gonna be important, it's gonna come up. Okay, so understand what it means. Those could be things that would be multiple choice, but like I say, there's probably gonna be a problem-solving question to do with vertical circular motion. What do we need to remember? Problem-solving for vertical circular motion. Right, forces in minus forces out. Okay, so right here, what's that force? Force of gravity. What's this force?
That's normal.
That's normal force. Which one's bigger? They're the same if it's not moving. Since it's moving in a circle, one of them has to be bigger. Force normal. Okay, force normal has to be way bigger. If it's not, your net force is out of the circle and bad things are happening. Okay, because you're not going around the circle anymore. All right, so in this case, normal force is bigger because this is the point on the circle where you will always feel heavier. Okay, you'll always feel heavier here. You could feel heavier here at the top of the circle on the inside if you're going fast enough, but you can also feel weightless there. Okay, it all depends on how fast you're going. You would feel weightless here if you were traveling at what speed? The minimum speed, right? Okay, just fast enough to stay in the circle. You don't push on the circle doesn't push back. You feel apparently weightless because Fg is acting in, and if it's present, so is normal force. At the minimum speed, the normal force is 0, and you feel weightless. Okay? And then the other situation we dealt with is here. In this situation, you will always feel lighter. Okay? If you're not moving, well, you're not undergoing circular motion, so it doesn't count. Okay? But as soon as you are moving, you are going to feel a little bit lighter until you get to the point where you feel weightless. This is the vomit comet thing, right? Where they make that feeling. We watched all those videos of people in planes. Okay? So we could have normal force acting out, but it is always going to be smaller than the force of gravity and can actually become 0 if you go faster. All right? So those are the three situations, and again, there could be multiple choice items about the principles of it, but obviously there's going to be a problem-solving question, okay, to do with that. Okay. Everyone okay with that? All right. Gravitation. So universal gravitation. Okay, so in universal gravitation, okay, the force of gravity is between the two objects. Okay, it is a mutually attractive force between the two objects. Okay, and so in that case, then we would have not of one on the other, okay, but of them pulling on each other equally. So like the force an apple exerts on the earth is equal to the force the earth exerts on the apple. Okay, it's a mutually attractive force between the two. Since r is squared, what happens to the force of gravity as the objects move apart? it gets weaker exponentially. Yeah, it gets weaker exponentially because r is squared. So if I double the distance between the two, there's going to be 4 times less force between them. Okay? That's something that could be in a multiple choice question. All right, probably not going to have a universal gravitation problem for its own sake, but it is part of. No, I mean like in what kind of problems? What other kind of problems is that part of? Satellite motion questions. That's the next thing we talk about. So a satellite motion question kind of allows me to test 2 things in one question, which I'm all about doing on a final exam. Okay, because that makes the test more efficient and thus a little shorter for you. Okay, that's good for you. So I'll often have a question that's going to test more than one thing in it. Okay, so a satellite motion question says that the centripetal force is being provided by the force of gravity. Okay, and so that could be mv squared over r equals big G times m1 times m2, and this is m2 over here, okay, over r squared. So it could be like that. But we also dealt with some problems that involved the orbital period, okay, instead. So in that case, I have to substitute for v. All right, that means I've got to substitute this formula in for v here. But in this formula, v is squared. All right, so when I do that, okay, I've got to square this whole formula, so that'll look like this. Okay, 4 pi squared r squared t squared. And I just put it in there. Okay, now there's an r squared on the top and an r on the bottom. What happens to them? They cancel each other out. Okay, so there's still an r on the top, but it's no longer squared. Okay, everybody all right with that? Okay, so you are going to have a satellite motion question, I would think, okay, in the written response, because again, it allows me to be more efficient. All right, and we talked about gravitational field strength. Okay, which allows us to calculate the acceleration due to gravity, not the force of gravity, okay, related to 2 objects. Okay, again, that's a fairly simplistic concept, probably not going to be in the written response, okay, but certainly something that is going to come up. Okay. Okay, and that's where that unit ended, right? It was just a short unit. There really wasn't much there. And in terms of the final exam, I tried to make the final exam reflect how long each unit took in the course. So the circular motion unit counts for the least amount of marks on the final exam, okay, because it was the shortest unit. Now, they're not significantly different, okay? There are 4 units, and I mean, I didn't actually figure out the percentages, but it's pretty close. Like, circular motion might be 21% of the test. You know, dynamics might be closer to, 28, okay, and then, kinematics might be, 27, and then waves and simple harmonic motion might only be 23. Okay, like it's going to be, they're close, but there are some that are going to have a few more marks just by the nature of what's in them. Okay, and there are a couple of concepts that we talked about in more than one unit. Okay, we talked about conservation of energy in Unit 2 and Unit 4. Right, so it could be in either one. I'm probably not going to ask for it in both. Okay. On that note also, the final exam is not organized by unit in the written. Okay, it is pretty much by unit in the multiple choice, but in the written, because I'm trying to make it more efficient, some questions ask about stuff from 2 units. Okay, so it's not possible for me to say, this is a Unit 2 question when it also has a concept from Unit 4 in it. Okay, does that make sense? Don't get intimidated. I'm looking at some of your faces right now and you're going, oh my God, there's going to be questions on here that we've never, ever done before. Not really. Okay, even if there's a question that maybe you haven't done one exactly like it, the 2 parts of it are things you've done before. Okay, and you'd be able to figure it out. Okay, I'm not heartless. So for your final, this is my philosophy on final exams. Not everybody agrees with this. I like to think of them as wrong, okay? But I don't think the final exam is the place for me to ask the hardest questions I can think of. I've already done that, okay? That was your assignments and your unit exams. I asked hard questions on those, okay? The challenge, what makes a final exam difficult is the amount of material that's on it, not the level of difficulty of the material on it, okay? So your final exam is challenging, but not because I just made ignorant, difficult questions, okay? It's difficult because there's so much to know. Okay. All right, anything in particular you would like to ask about or see done for Unit 3?
Can we just go over universal gravitation question?
Okay, so you're not gonna have a written response
No.
item about that,
Okay.
okay? But I can
Is
go
it,
over
can we
it.
do a satellite motion one? Then?
Satellite motion one, yeah. Okay, so. All right, that's a tough one. Okay, that would be a tough satellite question. I forgot, I changed something on the final exam, and there is a gravitational field strength problem on the exam. I changed a question, it used to be something else, now it's a gravitational field strength question. So, there is a gravitational field strength problem on or in the written part of the final. There are 3 written response items on this unit. So we're looking for altitude, which is not radius. Remember, we have to subtract the radius of the Earth in order to get altitude. So we are going to set this up as a satellite motion question. FC is going to equal FG. We're going to have to use the orbital period. So we're going to have to go M2, okay, times 4 pi squared times R over T squared equals big G times the mass of the Earth times mass 2 over R squared. Mass 2 is the mass of the satellite. It will cancel, okay, as it always does, which is good because we weren't told what it is. Okay, and we need to solve for R. Even though we don't really want R, we just need R to get what we want. Right? So I'm going to multiply both sides by R squared. So that's going to give me R cubed. I'm going to multiply both sides by T squared. And then divide both sides by 4 pi squared. And then I'm going to cube root my answer. Okay, so what I will have is 6.67 times 10 to the minus 11 times 5.98 times 10 to the 24, so mass of the Earth, okay, times 2.5 times 10 to the 4 squared, okay, divided by 4 pi squared. And that's cube rooted.
How come cube rooted?
Because R is cubed. Right? Like I multiplied R squared over to here. R squared times R is R cubed. Yeah? Is that okay? All right, so I need 4. 6.67 to 11. Okay, so there's my orbital radius, okay? 1.85 times 10 to the 7. That actually makes pretty good sense, okay, as an answer, but that's not my final answer. Okay, I need to now do what in order to get the altitude? Subtract the radius of the Earth, so minus 6.37 times 10 to the 6, okay, and that will give me my altitude. So okay, so my final answer would be 1.2 times 10 to the 7 meters above the Earth's surface. Okay, that would be about as tricky as they could get, because I put in the above the surface altitude trick, and I gave you orbital period and nothing else. Okay, so that would be, I would say, the trickiest satellite question you could fear to get. All right, what else would we like to see or do? No?
Can we do a gravitational field strength problem?
Gravitational field strength problem, okay. Okay, make that one a little easier. I initially was going to say at what distance from the Earth's surface, but we'll go Earth's center instead and save a step. We're looking for the distance from the Earth's center, so we're looking for R on this one, okay, and we know what G is. Little g is going to be 9.15 newtons per kilogram or meters per second squared, either one, and we know that the mass causing the field is the Earth, 5.98 times 10 to the 24. Okay, so we've got little g equals big G times m over r squared. So r is going to equal the square root of big G times m over little g. Okay, so that'll be 6.67 times 10 to the minus 11 times 5.98 times 10 to the 24 divided by 9.15. Okay, so we're looking at 6.60 times 10 to the 6 meters, okay, which makes perfect sense. At 6.37, it's 9.81. At 6.6 times 10 to the 6, it should be a little less. Oh wait, that doesn't make sense. It's more. Weird. Did I mess up a number somewhere? Very, very strange.
You're missing a bracket in front of the 9 there.
Yeah, I don't need it though.
Okay.
It's still gonna, like, cause I enclosed the top, so it should still be dividing the top by the bottom. You're right, like, in order to make it symmetrical.
It just didn't look right.
But, no, that makes sense. What am I saying? I got it backwards. That makes total sense. It should be farther. Yeah, that number should be bigger because acceleration is smaller. I need to go back to bed. That's what it is. I need to go back to bed. That answer makes perfect sense.
If you're measuring from the surface, would you just subtract the Earth's radius from
that number.
radius?
Yeah, and it would be like, what, 3 kilometers or something, right?
2.3 times 10 to the 5.
2.3 times 10 to the 5, okay.
Okay, that makes sense.
Yeah. Okay, what else?
Since he's-
Do we do a vertical circular motion?
Vertical circular motion. See, I figured you guys would ask about the 3 questions I said would be on the final. I don't know what gave me that idea, but.
Great drawing.
I know, it was pretty exceptional, actually. Okay, so we got this roller coaster going over the top of a vertical circle. The radius of the vertical circle is 31 meters. It's moving at 5.9 meters per second. Its mass is 200 kilograms. I want its apparent weight. So if I want to get the apparent weight, I'm looking for normal force. Because we're going over the top of a vertical circle, the force in is gravity. The force out is the one I'm looking for, normal force. So before I do anything else, I'm going to actually manipulate this formula so that I've got normal force as a positive number by itself. So I'm going to do that by adding it over to this side and then subtracting Fc over to the other side. So what I'm going to be left with is that normal force equals Fg minus Fc. Like so. All right, and that makes sense. This is the biggest force here, mg. I'm subtracting the centripetal force. That should leave me with the smaller of the 2 forces acting out of the circle. Okay, so when I plug in my numbers here, that'll be 200 times 9.81 minus 200 times 5.9 squared divided by 31. Okay, so the apparent weight is going to be 1.7 times 10 to the 3 newtons. Okay, everybody all right with that? That's probably about as tricky as they get. Okay, I think the one you had on your unit exam was pretty similar to that, actually.
For apparent weight, do you need to give a vector, or is it just...
No, on this one you wouldn't necessarily need to give a vector because it's how heavy they feel. Right? Yeah. I mean, if you put up, it wouldn't be wrong.
Right.
Yeah. Okay, any other ones?
Because you said now that there is a universal gravitation.
No, I said there's a gravitational field strength,
Oh,
which is one we did one already.
okay. Yep. So there's a satellite motion, gravitational field strength, and a
And
circular
a vertical circular motion question.
Okay.
Yeah. Okay, so one of each of those, and then there's 3 multiple choice questions. So, like I said, by far the shortest of the units. So the whole final exam is out of 85. Okay. There are 21 multiple choice questions. So it's like there are less multiple choice questions on the final than there were on 3 out of the 4 unit exams. Okay, so the multiple choice part is quite short. There are 12 written. Okay, most of your unit exams have had 8, but they've had more multiple choice. Right, so it should still easily fit in a 2-hour exam slot. Okay, because making the key only took me, what was it? I did it back in December now. I feel it was like 23 or 24 minutes. Now, I don't expect you're going to complete this exam in 23 minutes or 24 minutes. Okay, obviously I'm going to do it faster, but if I can multiply what I took to do it by 4, and it fits in the time you have, I feel like it's fair, and I can. Okay? So it should be okay for time. At the same time, speaking of time, one of the things I see happen often that I really want you to avoid is stalling. Okay? And I don't mean like you're purposefully taking longer. I mean like you stall on a question. If you read a question and you don't know how to do it within 30 seconds of reading it, move on. Okay, leave it. It will still be there when you've done everything else on the test. And then you can sit and be frustrated and stare at it for as long as you want. Okay, but if you sit there and stare at it and it prevents you from doing the questions you can do, that's bad. Okay, and I see it happen all the time. Right? And so I like walking by and I can see that someone's been on the same question for like 15 minutes. And I'm just like, look, move on. Okay? It really, 30 seconds. If you don't know how to even start it in 30 seconds, let it go. Okay? It's one question. Okay? If at the end of the test that question doesn't get done, that's better than 6 questions not getting done. Okay? And in fact, I would recommend you do this. Totally up to you, you don't have to, but if I would recommend it. Read through the test. Take 5 minutes at the beginning of the test, read through the test, and if you see a question that you are like super confident in, do it first. I don't care if it's question number 12. Okay, do it first. You feel good about yourself then. Okay, God, I rocked that question, that was awesome. Okay, I'm gonna move on to the next one. Okay, you don't have to do the test in order. Okay, do the ones you're confident in. Okay, you A, have them done, and B, you get to ride the confidence wave for a while. Okay, that feels good. And then when you're confident, you can approach questions you're scared of a little better. Okay, because you have that confidence. So that's my recommendation. You don't have to do it. Okay, it's something I learned but didn't learn till like university. You know, after stalling on questions and failing to complete exams. Yeah, so you don't want to do that. It's frightening. Yeah, it sucks. So do the ones you can do. Do them first. Okay? All right, what do we got here? We got 5 minutes left, right?
We got like 10 minutes.
10 minutes.
it's
No,
10:28.
10:28. So yeah, we got 5 minutes left. What do you need to bring to your final? Calculator. And
Pencil.
something to write with. Not a 5-course meal. Okay, don't do that. Okay. Just come ready. You guys are writing in here, remember? Okay, 9 o'clock on January 26th. Also a reminder of that overdue assignment deadline. If there's anything you want to have marked and entered into your grades, January 18th at 3:20, please.
That's
Must
Wednesday.
have it by then.
Wednesday. End of Wednesday.
That's Wednesday. That way when you come to my class on Thursday, you know exactly what you're going into the final with. Okay? Okay, remember, this is the first time you've like written a legit final with no, COVID stuff attached to it, ever in high school for most of you, I would think. So keep that in mind. It's worth something this time. Okay?
What is
There's
it?
not any no-fault stuff on this one. This one is a go. Okay? So prepare accordingly.
What is it rated? What percentage?
20? Yeah. I change it every year, so I can never remember what I made it. But yeah, okay. We'll go with that.
It 25 on that.
It says 25 on the syllabus. That's what I thought. Okay, hang on. Let's have a look here.
Well, I think you made our unit test like weighted more, so.
No, it's whatever it says on the syllabus. That's what I have it set as. So let's have a look here. Other important materials. Course syllabus. 25. So 25 is 1/4. 1/4 of your mark. Okay, so make sure you're ready. And reminder that the help sessions are January 20th and January 24th at 11. Right? You can come in here, look at your old tests, okay, ask questions, whatever. I don't know if you're going to need to because we're going to have 4 review days, but totally up to you. I'm available if you need it. Okay.
Have you ever had kids get 100 on the phone?
Twice.
That's cool. I can't even.
And I've had one person get 100% in the course.
Really?
I mean, you have to be pretty exceptional to get 100%. Never make a mistake. Okay? Like, I mean, I've had people get 99, you know, like that happened a number of times. But you can still get 100 even if you make like a mistake on one quiz or something. That's still mathematically round up.
Well, it's like, yeah, it's like the dumb mistakes that just add up by the end of the year.
Yeah.
It's like forgetting to put a vector.
Yeah, exactly. So to get 100%, like that's pretty exceptional.
That is insane. What, was that quite a few years ago?